Thank you, IndyPy. Thank you, 6 Feet Up. Thank you, Calvin, old friend of mine, for inviting me to give this talk. But not only that, for running this damn thing, a web conference. Who'd have thunk that we really needed it in 2019? But just before this, I went and looked at the talk schedule at PyCon 2019, this past PyCon. Out of the first 20 talks, you want to know how many were web? So a web conference, virtual or otherwise, great thing to be doing. Thank you. This is going to be a little bit of a scattered keynote. I apologize. It was assembled late because I was at PyBay this past weekend interviewing some key people in the world of Python about this talk about Python and the modern web. I don't know if you can see down in the corner the number of slides. You do the division, number of minutes. I got a lot to cover. I apologize for not trimming it down, but I wanted to leave it in and leave the slides so you could go back to see it later to start framing a conversation. A little bit about me. I'm developer advocate for PyCharm. Great gig. Lucky to have it. You don't see my slides. Okay. That must be the full screen. Let's see. Thank you for bringing that up. Now you see it, right? Yay. Thank you for mentioning that. Now I'll go into full screen. Give me another yay if you see it again. Yay. All right, cool. Apologies for that. As soon as I went in full screen, it hid the dialog box telling me to finish sharing my screen. A little bit about me. I'm developer advocate for I should be paying them. Great gig, great people. Don't tell them I said that. I've done a lot of things in the world of Python over the years, in the world of Python and the web. I'll skip over that and just to talk about how old I actually am. This is me as a young Navy officer in 1993, the first trace of me on the internet asking a question answered by, of all people, the creator of, realistically, the creator of the first web browser, co-founder of Netscape, rich as all bejeebas, Mark Andreessen, venture capitalist. Clearly, he and I took two forks in the road. He's got the better fork than me. This talk, let's make a hypothesis about Python and the modern web. That we have a blind spot about this thing called the modern web. And there have been two keynotes recently that covered this and kind of intimated that this could be a threat, a big threat. Let's explore that idea. And the outline of this talk is to go over those two keynotes. They were fantastic. They helped frame this. And then this talk is kind of the third in that sequence. What is this modern web? When I use that expression, what do I mean? What don't I mean? How's Python doing at that modern web thing? And what could it do? And then close out with a little bit of a call to action. So the first of those two keynotes, Russell Keith-Magee at PyCon gave a keynote about Black Swans. Fantastic talk. Highly encourage everyone to go see it. Really, really meaningful talk, unlike most of my talks. And in the Black Swan talk, he framed Black Swans as a surprise that hits something which dramatically alters the popularity of that thing. Could be a positive, could be a negative, but no one saw it coming. And then in hindsight, it looks very obvious. It's a surprise. So what do you do for surprises? You can't plan for surprises, but what he says is you can actively challenge your thinking, make sure you don't fall into groupthink, look for blind spots, try to plan accordingly. And for the purposes of this talk, he talked about several different Black Swans, three in fact, but one of them was Python and web. And as he talked about, he comes from a background as an early person and contributor to Django, quite famous in that community. And when Django started, was kind of the end when my thing was finishing. Thank you, Django. The code was on the server. You generated some HTML and CSS. Maybe you sprinkle in a little bit of JavaScript to make a search box pop out or something like that. That was web development. Python was great at it. Part of, at least at that time, arguably now, the key mission of Python, where the money comes from, where the users come from, where the energy comes from. Then over time, a little bit more of the value, at least what the customer perceived or the user perceived as the value, started executing in the browser. And as he frames it, there becomes this progression where, you do a little bit of enhancement, progressive web enhancement, you do a little bit of JavaScript, and then that becomes key business logic, the thing the customer values running in the browser. And it's not a big leap to think that the next part becomes, why are we doing that Python thing on the server? Can't we just use the thing we're doing for the key business logic? Which is the risk. And if you're talking about black swans and you're thinking about wildfires that could let happen, don't just sit and wait for the wildfire and do 100x the work trying to put it out. Go do a fraction of the work to clear the forest first. As he mentions, this is a big topic. Not everyone's going to agree that this is an issue, much less what to do about it or whether Python should change. So first, we need to start a conversation. His point is establish some consensus about what this is, what this isn't, the urgency of it, what needs to be done. In his talk, highly recommended if you only see the one snippet about it, he talks about the America's Cup yachting race. And for decades, the rules were kind of rigged in favor of the Americans. Henceforth, the Americans won all the time. And the Australians then went and did something sneaky. They changed the way the keel of the yacht worked and put a hydrodynamic wing on it and hid it so that no one could see it until after the race. And they won the damn thing. So rather than complaining about the rules, they went and did a black swan. They changed everything and they kind of used the rules to their advantage. He feels like the winged keel for Python and web is WebAssembly. In its early days, from my perspective, WebAssembly is so far out there that we shouldn't think of it as something that's going to help us in the next 5 years. It's got a long way to go. But that can be a strength as well. Exploit this game changer and exploit this things are going to change dramatically, and exploit the time before it all lands to go get a competitive advantage. So instead of complaining after the fact that, hey, why aren't we getting why are our customers dried up? Why is our sales funnel gone? Why is no one interested in Python and web? Instead of complaining about that, let's go exploit it to our advantage. And when the yacht pulls in, we're ready for it. When WebAssembly arrives, we're ready for it. As a co-founder of Zope, I have a little bit of experience for when you wake up one day and no one is interested anymore. Russell has another talk. I think the title of it is Beyond Web 2.0. It's, I think, a couple of years ago, maybe 2016. Where he starts hinting at this about around the time when universal JavaScript or isomorphic JavaScript became something that was talked about. This is JavaScript that is running both on the client and the same JavaScript running on the server under Node.js. This is a big deal for Python. I'm going to talk about it later. This is like the mortal threat. And he talks about it a little bit in that talk. On to the second in this series of topics leading to Python and the modern web. Łukasz Langa at PyLondinium a couple months ago, I believe. He gave a keynote. First, it's a wonderful keynote. Damn you, Łukasz Langa. It's well prepared, well presented, well researched. He's smart, all that stuff. And it's powerful. And one of the segments in there is talking about the past, present, and future of Python and CPython and the web as a platform. And the web as a platform, which could be a serious threat to the world of Python. In it, if you skip over to where this screen, I guess 28 minutes, 20 seconds, he starts talking about we need a Python compiler for the web in order to take advantage of the web as a platform. We can't just lose to JavaScript on the browser becoming JavaScript in the server. he kind of argues a little bit of a black swan point, similar to Russell, that we may have narrowly dodged a black swan or extinction level event in the change from Python 2 to 3. We might have been dead already, but it was data science that came out of nowhere to some extent, and wasn't really planned by the world of Python, and gave us this enormous injection of energy and buzz and people and adoption and things like that. And my take on it, I'm not that big into Jupyter, but my take as an observer is we got lucky. No one told the Jupyter folks to do Jupyter. And I suspect that if they would have put out kind of an RFC, they would have gotten laughed at the idea of a web server where people type Python into a browser that then shares mathematical oriented programming for a new group of people called data scientists. And yet it caught on bigly, despite the fact that it probably wasn't what CPython or the core Python community would have done if it was up to them. Łukasz then goes on to give kind of stats from both sides of the same coin. Things are great, things aren't great. Python, according to Stack Overflow, he gave several stats, but according to Stack Overflow, is the most wanted language. Python has hit the sweet spot of the language people enjoy and want to know. But then if you look at another stat on most popular, and this one's interesting because there are other stats that show Python's the #1 programming language, Python is the most popular, fastest growing, or all these other things, and things seem great. Like, why do we have a problem? This is the best it's ever been. But on this stat, #1 is JavaScript, #2 is HTML, #3 is CSS, something else is #4, Python's #5. And kind of a point from that is the web platform is still the whole enchilada. It's the big thing out there. And if Python could come up with a story for the web platform, and instead, if we could come up with a story instead of being extinction level event, it could be an opportunity for huge growth because people love us. People want to use Python. But his assertion is also, don't undersell the challenge. Modern web is a high bar to clear. It needs to be a clear story on the client, meaning a journalist goes to python.org and is messaged that we are legit, we are competitive. It needs to be supported. It can't be some side project that has 1 or 2 contributors and a release every 2 years. It needs to feel as solid as Django felt in web application development for a decade. And if Python could get something like that, then we could start to change the story. He also talks about how hard it is to do things in Python these days, that volunteer-led efforts, especially strategic efforts, are a challenge for a project like Python. Some of you may be following this already and saying, well, what about PyIodide or some of these other experiments, Brython, for example, that have gotten a Python runtime, Python interpreter in the browser? Isn't that proof that we're already on the right track? Well, it's proof that things are starting to happen and WebAssembly is starting to be thought of by Python people. But he kind of shoots a little bit of a hole in that and points out first, it's a megabyte download. When we talk about clear and supported client-side story and production quality, like down here, professional and production use, 2G phones in Africa are not going to tolerate a 1 megabyte download. We'll talk about why a little bit later. And it isn't just the download size. You could do MicroPython and maybe get it down to 300 kilobytes, which is within an order of magnitude of React, but it's going to then be the execution time. Sending everything through an interpreter before it can start drawing to the DOM is going to be an order of magnitude slower than some of these other alternatives, such as the highly tuned React, which runs in the highly tuned JavaScript interpreters, which have bazillions of funded corporate man hours going into optimizing them. So what we need is a new kind of Python. This was a very, very good talk. I highly encourage you to not just watch it, but rewatch it and study it and take some notes and go research some of the things that it points to. Okay, let me check on time. All right, doing all right. Let's switch from the previous two talks that helped frame this conversation and talk about this phrase I'm using called modern web. Infinitely elastic term. Let's try and make it a little bit more specific. I'm going to frame modern web by what's driving it, what's the industry need, what are some statistics that support the need for it, and then what are some of the metrics that have been developed for helping you know whether you're doing the right thing. And then I'm going to go into progressive web applications, what that specifically means, kind of the first generation of modern web. And then the purple pattern from Google, which is the second generation, again, in my opinion. And then a single product called Gatsby that implements it. And then how a couple of the factors introduced in these are bad for Python. First, drivers. In the beginning, we'll say, 5 years ago, is that how long PWAs has been around? 4, 5, 6 years ago? The goal was this, so that the web didn't get obsoleted on mobile devices by native apps, native mobile apps. And progressive web applications, PWA, became the answer for how you could add a web page to a home screen. More recently, there's this thing called Purple. I'll give you the acronym in just a second. And it's raising the bar quite a lot, saying not just get on the home screen, but be competitive with native apps once you're there. High performance on cheap phones, on slow networks, possibly in Africa, which is a problem that's not just bandwidth. How long does it take to transfer? How long does it take to render? And if you're sending stuff through JavaScript and it's got to be interpreted, it doesn't matter if you already have the JavaScript. The slower is parsing, interpreting, and then what's the effect on battery life? And I'm going to give some business stats along the way to help explain this, the drivers. This is a great series from Google under Web Fundamentals. I'm going to cite a number of them. This one in specific gives the business case for why performance matters. Quite a few just on this screenshot from different sources. The one that I've underlined is kind of shocking to me. As a Zope guy, as a Plone guy, as a Pyramid guy, as a whatever guy, 3 seconds on some of our sites were like, if you could get if you could get the first byte of HTML off the server and out the door in 3 seconds, it's like, yeah. But if the goal now is start drawing on this screen in Africa in 3 seconds, we have a lot of other things to start thinking about that we don't think about enough. But kind of the point of this is, if you don't think about these things, then people are going to bail on loading your page before it's finished delivering, and you're going to suffer as a business. My summer reading material, this at the beach, very good application. Chris Love, who's kind of a contrarian on progressive web applications. And in this, about the kind of the first poster case of progressive web, Flipkart. And it puts the progressive in PWA. They took their existing site. They didn't convert it all to some big JavaScript framework. They took their existing site, did a couple of things very quickly by a small team, and saw a bunch of numbers get really better. And these are things that drive business. They're not just geek love things. He has a website where he talks about other reasons to care about PWAs. This is another contrarian view, the impact on SEO. And here's the contrarian view. I spent a lot of time over in React and TypeScript and Gatsby and WebStorm, the front end world. And I'm like, yeah, man, give me some more of that framework stuff. I love it. This is geek heaven. And when the topic came up about, oh yeah, how's Google going to index that dynamically rendered single page application? For the longest time, it was, let's hope that no one mentions that. And then Google said, okay, we're going to start indexing single page applications. Yay, we're out of jail. Chris Love points out, no, you're not out of jail. You just think you're out of jail. What happens is Google says, oh, single page application, that's going to take a lot of our CPU cycles to index it, maybe like 3 orders of magnitude more than the HTML. So we're going to index you occasionally. We'll be back in a month to see if you've changed. And also, we're going to ding you on your search score because it takes 15 seconds to get the first byte, first pixel on a screen for a 2G phone in Africa. And that is helping to drive some of the things I'm going to talk about regarding modern web. Let's switch over to metrics that define the modern web instead of stats that define the business case. Here's another page from Google about rendering on the web. Later on in this page, they start throwing out some performance numbers. Time to first byte, which is what we generally have thought about. How long does it take to like render your Django page or your Plone page and get the HTML pumped over to the browser? But that's not really the goal anymore. First paint is a big goal. And a lot of factors go into first paint, including, does everything have to go through a JavaScript React runtime in order to draw the first pixel? And then time to interactive is another, well, I should say first contentful paint. And then time to interactive is another key metric driving some of these things like lighthouse scores and how to know if you're doing a good job on the modern web. Now, this page also has under terminology some acronyms and terms related to rendering that are scary as hell. This one, server-side rendering, the biggest threat that we have. Rehydration related to that, pre-rendering. And when I say scary as hell, I spent a lot of time with Gatsby, so I know a lot about it. Static rendering is scary. What this means is the dynamic component that's going to render in the customer's phone or desktop or whatever that they're going to interact with, and the thing that your customer thinks is valuable, we're going to accelerate it by pre-rendering it the same implementation on the server. That React component that's running in Chrome is going to be a React component running in Node.js. We're going to do a build step, and we're going to spew 12,000 HTML pages. And so when someone walks up to a URL, instead of getting a pile of JavaScript, maybe they already had it, getting a pile of JSON, going through the interpreter loop and going through the React, this, that, and the other thing, and drawing the first bit, instead, we're going to send the first bit. We're going to send the HTML. It's going to get into the browser, and then we're going to go load the JavaScript component, the React component. It's going to come up and rehydrate all those DOM nodes. They're not going to change because what they're going to render is already in the DOM, but they're going to do the virtual DOM diff thing and attach all the event handlers. And from that point on, it's a client-side component. Note the fact that the React component was written to run in the browser and then runs in the server. In what language would that be? All right, switch over to the first and second stab at kind of defining modern web. Progressive web applications, PWAs, this is considered the blog post that started it all. How to get on the home screen of a phone. And with the PWA, it's really 3 things. It's this manifest file that helps a page, web page, transition to being a web app. It says like, here's the icon and here's the assets you should load and some other things. HTTPS is part of the spec. You can't do a PWA over unsecure HTTP. And then something called a service worker, which is a little snippet of JavaScript. It runs in, we'll call it a background thread, so it doesn't block the main UI. And it does the just little bit of stuff to interact with the host system. There's some other things that are sometimes thought of as part of PWA, Appshells, and these various APIs that are now part of all browsers that can be reliably used. But that's not critical to the idea of PWA. What's more important is a current attempt to define a scorecard and a measurement system to put some meaning behind modern web, the purple pattern from Google. And the hypothesis, the theory is, and this is talking about like Moby Dick, the first line of Moby Dick, "Call me Ishmael" is the best first line in the history of literature. This is heck of a first line. The mobile web is too slow. That is the business case for the modern web. What Addy goes into defining is purple means push, render, pre-cache, lazy load, trying to accomplish a set of goals which are a higher bar than what we in the Python web community are used to caring about and thinking about. And when we do care about it, we just switch over to REST and write the important stuff in JavaScript, which is what I'll talk about in a little bit. Purple implies a number of things, a number of, we'll say, technologies that are important to delivery of that. They're patterns, we'll call them. This concept of an app shell where, and we've been used to this for a long time, where most of the pages on the site have a header, they have a footer, they may have a sidebar, the things that don't necessarily change, and then there's a content area in the middle that changes. And maybe you can have some strategies client side to accelerate the experience by not going back to the server to get the app shell, which then implies client-side routing. You click on a link and you don't reload the universe, which also implies having some dynamic execution in the browser where your components and templating and VDOM and things like that. Once you go down that path, in order to get 2G in Africa, you don't want to load the universe on every page, so you split your code and only load what's necessary for that route. And then the big one, server-side rendering. If you decide that to get your lighthouse scores and to get your customer targets and to get your search engine optimization, you need to pre-render on the server, then that means all of that stuff that we just wrote in JavaScript and React, etc., we're also going to do that on the server under Node.js. An exemplar of this, GatsbyJS, it's the poster child for modern web. It's been a big, big, big deal. It's gotten a lot of buzz. I believe even the Plone community talks a little bit about it. And I've been knee-deep in GatsbyJS for the last 9 months, writing some pretty low-level stuff, reporting bugs about the architecture, things like that. I've gotten really familiar with it. What's the big thing about GatsbyJS? It's freaking fast. It does the purple pattern and things load fast even on phones. It goes to the end of the earth to give a positive developer experience, yielding these purple things without having necessarily to understand them. And one way to think about it is you take a bunch of stuff in your CMS or maybe a bunch of markdown on disk or something, and you compile your website into something that will be delivered at optimum speed. Another aspect to it, and this is what Plone knows well back from its earliest days, it is an out-of-the-box system. It's a ready-to-go product that can be extended, and you don't necessarily have to build the universe. What does it do out of the box? Gotta say, it's going to be a long list. And as I go through these things, ask yourself, when was the last time someone in the Python community even talked about this? I'll try to stay on time. I'll go through these a little bit fast. It does the big one. Server-side React, you don't have to even understand it or think about it. It does it for you as part of the build step. So what do I mean by that? Let's say I'm doing a blog in Markdown. I write a React component that renders it. And when I build my site, it goes to all my markdown pages, generates a HTML output that renders the React component to an HTML string, but also injects a whole bunch of links to go reload that component later and rehydrate it so it becomes dynamic. It also does all the service worker push stuff. So it will generate the manifest file saying, these are all the important static assets. These are all the important URLs in the navigation that you're probably going to click on. Preload them. Use the service worker in the background thread. Somebody clicks on a link, goes to a site, gets the HTML, and then it says, oh, by the way, go give me all this other stuff that I'm probably going to need later. It does offline first. I was going to do a demo of this, my PyCharm guide site, and then I turn off the Wi-Fi, click around, and I'm still getting stuff. Gulp. It does code splitting, which is kind of a hard thing, and does it for you automatically. You don't have to think about it. And because it does SSR, it can run without JavaScript. You can go and get the initial JS and do a lot of things, even for things that turn off JavaScript, which means that its search engine optimization is going to be sky high. More things it does, it promotes the Appshell concept. This is a freaky thing. It will go and prefetch URLs. I talked about it a little bit, but it also decorates some links with the link relationship of prefetch. As you're scrolling down through the page, as links come into view, it will go prefetch those things. It does a good job of inlining the CSS that's needed for the critical rendering path, so you get the fast first paint. This is freaky. Perhaps the Plone community is already doing this, but let's say you have a page with a whole bunch of images on it. The images are probably way down here, so it doesn't fetch them until you start scrolling and the intersection observer DOM event fires, and it goes and gets that image. And it generates multiple resolutions of each image, so it will send the correct image using the image set support in HTML. And then it does some things related to GraphQL, which aren't relevant to the modern web part. On the other hand, living with Gatsby is a rough experience. I think it's like 12,000 NPM packages, 290 megs of node modules. Every time I walk back up to it, there are 5 to 12 security vulnerabilities reported on one of those packages, and I have to go resolve them. It is this enormous, unknowable tool chain. And personally, I feel like the Gatsby people with GraphQL and some of the other things have created more architecture than they can deal with. I would love to have a Gatsby in Python. It's a great opportunity. Learning from this in the modern web in Python, what are some of these mortal threats? The server-side rendering is by far the big mortal threat. If that becomes a thing, and it's arguable, there are people who don't believe that server-side rendering is worth the complexity. If it becomes a thing, we're in deep dookie. Because if they have to choose to do either JavaScript or Python, and they have to throw one of them out, they're going to throw us out and do Node.js on the server. Virtual DOM templating, we'll call it, JSX, is another thing. Just on templating, Python is in the late 90s. Essentially, all of our templating systems have the ASP, PHP style tag approach. Whereas almost all of the world of JavaScript has a very different concept about rendering a JavaScript construct called a virtual DOM, which then at very high speed re-renders the actual DOM. We're not even talking about that. There are two projects that I'm interested in, HyperPython and IJK, I think. But no, I mean, they have, compared to Jinja 2, no adoption. And then a whole bunch of other things that are mortal threats. Client-side routing has some of the business logic in it. If it becomes server-side routing, that business logic is in two places, two languages. Well, let's eliminate one of them, they'll eliminate Python. There's a recent proposal for speeding up the load time of JavaScript called binary AST. If that becomes a thing, and that is considered important for 2G in Africa, we're in trouble, because the only thing that can generate binary AST of Java will probably be JavaScript, How's Python doing on some of these things? Dangerously successful, I'll say. We are number one. We're kicking butt. Everyone loves us. What's the freaking problem? That's the time when you get killed. When you stop looking for the next thing, you stop thinking that dangers are dangerous, that, oh, we'll be okay. And we've got super popular alternatives, Django and Flask, but they are not remotely like Gatsby and some of these other modern web systems. We could say, well, yeah, but we've already got a solution to that. We'll be headless, and we'll do our front end in React and do the grown-up stuff in Python. But that leads to, in my opinion, a blind spot. I'll talk about it in a second. And as an exemplar, PyCon barely even talks about web anymore. So in the future of budget application, projects have budgets. It's not just money. It's like code budgets and HR budgets about who we're going to hire and what skills and things like that. Performance budget, how much of the time can you spend on this, that, or the other thing? And then value. Where's the business value? What do your customers care about? And if we start giving over some of this budget to JavaScript, and more budget to JavaScript, and more budget to JavaScript, at some point, projects are going to say, why do I need Python? And consultants are going to say, hey, I'm pretty happy with this. The customer's happy. I'm making money. But each line that's done in JavaScript is a shovel of dirt for Python's grave, in my opinion. But we can't expect the customer or consultant to do things that are bad for them. Python in the modern web, we're not competitive. We need to do more. What would more be? We could get an interpreter over into the browser. We could do something called Transcript. These are all interesting projects that you can pay attention to. Transcript is interesting to me because it's mature, it's feasible now. It does not send a browser over Python interpreter to the browser. It translates everything to JavaScript. And it has very good module support, ECMAScript module support. What it needs is a framework that can run on the server and the browser, something like HyperApp. And then a bunch of other things that we haven't started working on that we'll have to rethink if we want to be competitive in this sphere. So what's the action call to this? We need to have a conversation in the Python community to decide this is a thing, it's important. We need to establish consensus and start doing some things about it. We don't need to go start writing code. We need to do storytelling and organizing our thinking on it. We might need a killer app that causes people to adopt these ideas just because they're sexy. And in conclusion, people love Python. Let's not view this just as catching up. Let's view this as kicking ass. Thank you. For questions, I don't see any questions posed right now, but I will stick around and answer any questions that come up. They might be in Slack as well.
I'm back with you, Paul. Can you hear me, Paul?
I can hear you.
Oh, awesome. That was an amazing talk. Thank you very much for joining us.
Thank you.
I don't know if we've gotten any questions. I don't see anything in the QA. Do you? But Paul, you'll be around all day, or at least on Slack?
Yep, I'll be sticking around certainly this morning.
Okay, awesome. Well, again, if people have questions for any of the speakers, hopefully they'll kind of be around, or at least ambiently around on Slack. I think they'll give people that hallway experience that they were hoping to get from a conference like this. Again, thank you very much for Paul. I'd say give us all a virtual round of applause, but I think you probably only hear me clapping, so I don't know, how effective that really would be. But there we have it. Again, I'm really excited you were able to join us today. Glad it fit into the schedule just right, and I love the topic.